Greetings. In recent years, investors in Silicon Valley and beyond have been pumping more cash than ever into self-driving cars. However, beyond the focus on passenger vehicles, another sector that's getting a lot of attention are haulers. So commercial vehicles that are working on the highway, sharing spaces with passenger vehicles. But beyond this, there's a lot of interesting new core work happening in off-highway autonomy space as well. There are a lot of geofenced, low-speed autonomy solutions that could be very useful and have a lot of value. We're also seeing a lot of autonomy applications in controlled environments where they're working on private property with fewer regulations. They are less restrictive on driving sectors. Some of these examples are hub-to-hub connections, vehicle maneuvering in yard applications. We're also looking at mining and agriculture sectors where we're seeing a lot of automated vehicles. And the military, of course, is looking at autonomous systems as well, primarily as force multipliers and for occupant safety. So good afternoon, good evening, and good morning, everyone. Thank you for joining me today. My name is Prachi Vakaria. I live and work in Washington, D.C. I work with the Massachusetts government on automation, and I'm also working with a company called Safe AI that's based out of California that's focused on automated vehicles for mining applications. And with me today are two amazing panelists from around the world. Please welcome me as I get joined by Ben from Blue White Robotics, Aubrey from Bear Flag Robotics, and Sukru from Pilot Car. So why don't we have each of the panelists give a brief introduction of themselves. Ben, can I have you go first?
Prachi, thank you for this panel, and I think it's an amazing panel. And I think it's a very exciting panel because we're talking about things that are actually happening and not just future mobility. So I'm very glad to be here. My name is Ben. I founded the company about 4 years ago, Blue White Robotics. We come from the military industry and the Air Force and other places where we have done autonomous vehicles for the last 25 years. And it seems like this decade is the decade to implement those capabilities outside in the real world. For us, working out right here, this is the ideas of what we are doing is to help in this revolution of these industries through autonomy, through the understanding of autonomy. The things that we're doing these days, especially in the agriculture business, especially in permanent crops. I'm speaking to you now from California, and we're an Israeli company. And the idea of what we're doing is that we have a platform that enables numerous amounts of vehicles to run around, whether it be by our AV kit that transform any vehicle, whether it be John Deere, New Holland, or any other color that you can find, with unique onboard capabilities and AI, and it's connected to our software platform that has the ability of one person operating multiple amounts of vehicles in these areas. And we are very happy that in the last 2 years working around in agriculture business, we're doing actual operations, even during the pandemic that has been with us. And it's very exciting. And I see here also people from that industry, and I think it's amazing what all of us are doing.
Thanks, Ben. Over to you, Sukru, if you can share a brief introduction of yourself and of Pilot Car.
Hello, everybody. My name is Şükrü Özkılıç, and I'm co-founder and CEO of Pilot Car Electric Vehicles. I have been in this industry for over 10 years, and our company is based in Turkey. We manufacture electric golf and utility vehicles, utility carts, and also low-speed vehicles and street-legal vehicles. Last 3 years, we focused on last-mile delivery vehicles, and we launched Turkey's first street-legal electric mini-truck to the market. We have also other operations in Europe and United States of America for this business. However, I'm now representing a partnership of an autonomous utility vehicle project as an OEM. Our partnership consists of 3 companies, which are Pilot Car Electric Vehicles as a platform provider, Imecar Electronics as technology provider, which includes drive-by-wire systems, batteries, wireless charging systems, etc. And Carteo is the other member of this partnership, which has a deep experience about autonomous driving. They bring our project hardware, software of autonomous driving systems, and also site management softwares. I'm so glad to be in this panel, and I'm very thankful for this opportunity.
Wonderful to have you here as well. Aubrey, tell us a bit more about Bearflag Robotics.
Yeah, sure. Nice to meet you. Nice to be here, Prachi. Thanks for having us. So great to be here with you guys, building tech that's not really the future of mobility, it's today. So thanks for having me. I'm founder and COO of Bearflag Robotics. And what we do at Bearflag is we build autonomous technology for farm tractors. We don't, like Ben, we don't build the tractors ourselves. We implement the sensors, the actuators, the compute onto tractors, and what we focus on is automating all of the phases of the farming life cycle. We monitor soil health. We monitor what's going on with plants as we're farming them, so that once we can link these together, we can help growers make better decisions and their agronomists make better decisions about how to farm in a given season and in the future. So thanks for having me. Excited to be here.
Thank you for sharing that, Aubrey. So my question to all the panelists is, why are you in these sectors of agriculture, Shukru, with the sectors that you're in as well? Are we finding more R&D dollars? Like I mentioned in my introduction, there's so much money pumped into passenger vehicles. So what's really driving the demand here? Is it that the ROI is realized faster, or it's realized even higher than one would expect, again, in passenger vehicles? Why are you in these sectors?
Aubrey, go on it. Go for it.
Should I go first? Okay.
Yeah, go for
well,
it.
So for us in agriculture, it's not so much a nice to have, it's a necessity. And what we're seeing, the macro trends in agriculture, and by the way, our Bearflag Robotics is based in Northern California, and in the United States, California is the largest producer of food. So, I mean, you throw a stone and you hit a farm where we are, and it's very important to the state of California. But the macro trends that we're seeing that are affecting growers not only on the West Coast in the US, but also in the Midwest, where we grow a ton of food, and other places around the world, is labor scarcity. Less and less people are going into equipment operator jobs. It's making these jobs harder to fill, more costly for growers. And then the other big thing that we're seeing is climate change. And growers, they're having to do a lot more in less time because of weather pressure, frankly. And so the demand for this technology is immense. When we founded Bearflag, we were looking at other applications. We were looking at mining and construction and things where you do see a trend in labor scarcity and a high kind of a good use case. Like, we're all talking about industrial automation, low speeds, controlled environments, wonderful use cases for automation. But agriculture is really what pulled us because of the demand. And we're able to give, with autonomous tech, it's amazing. We're able to increase the productivity that a grower has. They never have been able to operate at night. We can move them up to 24 hours. That means that they can turn more crops, make more yield, and then they can do more in the small amount of time that they have, let's say between a harvest and a planting for the next season, which is so critical, and it is tied to yields. So, you know, it's a place, we're not taking technology and finding a place that could use it. It's a pull, which is great to be in.
That makes a lot of sense. Go ahead,
Just to add in this industry altogether, I think it's also, just like Aubrey said, with the huge pain that we are addressing, it's also the availability of technology. I think what happened in the investment in urban mobility that caused a lot of sensors pricing to go down and a lot of capabilities to be much more feasible. the growers and both our clients are seeing ROI at day one. Okay, you see the return on the investment is much faster, and we're talking about people who have huge revenues but very low margins, and the ability to create something that is we're talking about 25% of the yearly expenses on labor, if they were available, that can be addressed at day one. So it's huge pain coming together with the availability of technology, and all the stars are aligning. And Bear Flag Robotics that are going for raw crops, and us that are doing permanent crops. Things like driving in areas with no GPS or lack of communication, things that you could have only imagined 20 years ago in military areas are now available and suitable. And you can do it safe. And there is no reason for people to be spraying those chemicals with them running around. The only reason there is no regulation about it, that there is no other solution. So if you can bring those solutions and bring capabilities for a safer world, this is very exciting the way it happens. And to tell you the truth, I think the situation today is that demand is so high that we just need to make sure that we're delivering. So it's all about execution these days. And we found out, for example, that it creates new methods of models that are happening, such as a robot as a service, as an example, because we're talking about how do we create adoption? How do we create adoption in these areas? And you cannot throw those technologies on those industries. It doesn't matter what they'll be. And people want you to be there at night when the shit hits the fan, okay? So they want you over there. So the idea of bringing this as robot as a service, as an example, gives a lot of comfort to the end users, and they know that you are there for them at the end of the day. So very exciting times.
And really all day, given the 24-hour cycles. Shukri, tell us about from your perspective as well. I'll just give a quick example of mining sector as well. It extremely reflects what Aubrey, you and Ben mentioned as well, which is we're able to increase productivity while removing some of the uncertainties of labor. We are finding especially a lot of traction, Safe AI, in mining applications in Australia, where mines have gotten so remote that you cannot find any labor to work there. You have to fly them in, fly them out. And you have about 3.5 people or operators per vehicle. And if you're able to even reduce one shift, you can realize huge savings back for the mine owner.
Yeah, from our point of view, I have to summarize this in generally. Due to slow speed and well predefined geofence areas for our solution, the complexity of the solution is much more lower than public road autonomous vehicles. Therefore, the development and regulation and also return of investment should be much better. Our operational vehicles are used for transporting goods from point A to B or passengers. These services in many cases like resorts, airports, parks, hotels, factories, and so on continue for service nearly 16 hours or more hours a day. Employing a driver makes this service very expensive, and driverless vehicle, which will be a cost-effective way and provide better service than human. So for this scenario, the return of investment is immediate and very high. Even in cases of self-driving, having a vehicle that can be called empty and it can be shared between many people. So this will be more efficient and it can reduce the cost dramatically. And this industry is open for automation because it's a specific industry. And today's operational industry vehicles are low-tech due to us. So with our solution, it will be able to manage all vehicles and making reservations as Uber and reducing costs can change dramatically the type of usage and application in this industry. However, in our industry, we don't have huge R&D budgets. On the other hand, the required R&D budget for our solution is much lower than required in the regular automotive industry due to its usage environment, speed, and so on. So the scenarios we need to support are easier to implement and limited compared to normal road due to driver behavior. And the last thing I want to mention is about return of investment. And in case of saving the driver cost, return of investment can be from first month, since the autonomous software and sensor costs divided over 5 years, service will be lower than the monthly cost of the driver. Yeah.
That makes a lot of sense. I like that you touch on the R&D costs as well and how they're supported in terms in-house and then some with your partners that you develop as well. One of my questions is also the role of partners again, and the partners in the entire industry, not just your end client. So my question is really, what are the ecosystem requirements to allow the vehicle to operate autonomously? So what technology do you need? What interoperability needs do you have? Or what are the dependencies that you have as well? Again, from the SafeAir experience, I can tell you that we had to work with the mines or work with construction sites, but set up our own communication network on the site just because what they have did not meet our needs. We also, of course, had to do a lot of mapping, actually quite constantly, to ensure that our vehicle can move in the right place at the right time in the right direction. So tell us, who are your upstream and downstream ecosystem providers, and what's the onus on you versus your client to provide this technology interfaces? Any of you can go first.
I don't mind going first on that part. So I think all of us wants to do the minimum as possible and not to take the whole thing altogether. Otherwise, we won't succeed. Part of our core values of the company is fellowship, love of the land, and innovation. And in fellowship, it means that do what you do best and cooperate with others. And this is how we're looking at things. As for example, in the area of communication, coming to the US with our applications, we were sure that communication won't be as a problem as in Israel. We found out that it's even worse. In areas that are needed, you need the dual systems of both cellular and the RF capabilities. You need to integrate very complex capabilities. But the bright side is that also the huge companies who used to deal with those communication things, they want to be there and they understand the need. So we are cooperating, for example, with the 5G lab together with Team Microsoft and Intel, and we're working together in creating autonomous farms with the 5G capabilities at remote areas. It cannot be cost effective otherwise. With the needs of broader bands that will just go and increase day to day. Sensors, as I said, are much cheaper, and it's very good to do it on that side. As for the data analytics, we're a company that knows how to move equipment autonomously from one place to another at large scale. And if we are there already, the ability for us to collect a lot of data is there because we have those vehicles running around. We push these data to agronomists or data companies to create their own application, and again, to make it affordable for everybody. If the vendors have affordable data, it's also suitable for them to make it happen. So yes, as operators and as the companies that at the end of the day need to deliver to the end user capabilities and not just technology, we are in charge for a full solution. But the idea is to take as much as possible from other industries and from other capabilities and to implement it correctly at the right time with future-looking capabilities on how it will be along the days. So revolutions don't happen in one day. It takes a decade at least. In this business, we have, it was more than a century that nothing really happened in this area. And with the correct understanding and the correct implementation at the correct time, at the correct areas, and this is how it happens. So that's about it on my side.
The other panelists, would you agree? And what's your experience being integrating? I know at SafeVI, we also had to integrate with the mines, FMS systems, the fleet management systems. What has been your experience?
For the ecosystem, we can divide this ecosystem into two parts. One of them is product ecosystem. The other one is environment ecosystem. And product ecosystem consists of cart vendor as vehicle manufacturer, drive-by-wire capability and autonomous charging system, and autonomous driving software for the cart and site management of all operational vehicles, including reservation. And also all sensor manufacturers are in product side. The other side is environment ecosystem. Environment ecosystem consists of two things from our side. One of them is regulations. The other one is insurance side. We know that there isn't any global regulations for these types of vehicles operates in geofence areas. So these regulations has to be reorganized in terms of Ministry of Transportation guidelines and regarding to geofence areas. And also insurance companies that will need to define new types of site insurance. And we need technologies like 360 coverage around the car by multi-type of sensors, fusion algorithm that creates one integrated obstacle map, 20 millimeter navigation accuracy, and decision-making algorithm that unique for low-speed environment with pedestrians. However, we have also dependencies, and our biggest dependencies relies on sensors costs. However, we have a solution to be cost effective. Because of our solution is low speed vehicles, so family of sensors that are for short ranges like parking sensors in regular cars. Parking range is similar to our stopping range, so this will be a cost effective way for us to use on our vehicles.
And then I guess to offer a little bit more on the agricultural side, I would just echo connectivity as the major ecosystem dependency for us. We, early days in the company, we looked at local setups, but it's not scalable. And so we made a decision, an investment early on to architect a system that, we could support a whole fleet, many, many machines, dozens, maybe even hundreds of machines from remote locations. And part of that required thoughtfulness in our data pipeline and understanding what data is safety critical, what needs to be low latency coming off the machine versus what isn't safety critical, what is what we're going to use for post-run processing, and then how those pipelines come off the tractors and when. And so that's how we design the system. And so the part of the limitation is that we do need connectivity where we're going. And a lot of customers have it, luckily. But as Ben said, it is a journey and not all do. And so we do. If there's deep enough pockets, we can implement a network wherever you are. But in general, we look for places that we can scale pretty quickly in that regard. And then other, the thing about agriculture too is we find growers, and we have to meet growers where they are. We have to go on machines that support the implements that they already have as assets. We don't just show up with a machine that works for us. And so part of the onboarding process is configuring all of their existing assets. Because the tractor for us is just a vehicle. It doesn't do any farming on its own. It's the implements that you attach to the tractor that engage with the ground, engage with the plants, and that's farming. And so we not only just characterizing, what's the dynamics of that particular implement. And sometimes these implements are custom, that they attach 3 different implements to each other, and it's the one that they've been using for 20 years. They're not all standard. So some of that is custom work. But the bigger piece is not how do you drive autonomously with that implement. It's how do you monitor, and collate a lot of data coming off of the implement and the vehicle to predict, let's say, wheel slippage, where you might be a place on a farm where you need to stop the tractor and you need to have a human come and intervene. How do you monitor job quality behind the machine? There's a lot of vibration. There's a lot of environmental noise and stress on our systems. And so how do we monitor that using the various sensors that are on our stack together? And that can be quite complicated, and it's a lot of work, but it's one of those things that as we deploy more and take on more implements and take on more farms and more operations, our systems learn and become more adaptable to a variety of implements. And so that's, I'd say, and then the last piece of it for us, a lot of our team comes from an aerospace background. And so just safety, human safety is something that we talk about and think about. And it's at the genesis of every single design discussion that we have as a company. And with these very large machines, you don't just set it and forget it. These machines need refueling, for instance, and they need servicing, and they go down sometimes. And so humans are in this loop from time to time, even when 90% they're operating autonomously. And so a lot of our focus has been on the intersection of when a human needs to interact with the machine, or for instance, getting a machine down a public road to somewhere else. Perhaps you would have a human do some of those more complex operations that put other humans at risk. And so that's the other ecosystem requirement. And then to echo Bennett, again, you don't drop it in the hands of a customer before they're ready. And so you do need to provide that service until you can train, until that customer is ready to take on it's a new technology, but it looks the same. And that's the trick. You can't treat it the exact same as you could treat your vehicles before they were autonomous. So that's our challenge, but it's a good one.
Yeah. Quite agreed on all the points everyone's raised. You have to work with partners. You have to find ways to come together and find a solution together. So my question is, there's so much emphasis, like I started off in the beginning as well, so much emphasis on passenger vehicles. Has all the money, all the attention on passenger vehicles help or hurt the industry? Like Ben already pointed out, hey, all this money is really helping drive down the cost of sensors, drive down the cost of computing, and various other items you need to enable technology and enable autonomy. How is the case being for the rest of you as well? Where are you seeing the benefits of all this emphasis on passenger vehicles? And where are you seeing the costs on your industry? Do you wish that there was more emphasis on ag and more money was flowing into it?
I think we are at an amazing situation because first of all, this money that was invested did good for all the industries, and this is one. And there is a reason we evolved to the agriculture industry. The reason is that people, from investors to society, are not as patient as reality is, and they want to see things happening. And we are the good story. We show things that are really happening right now. And when you're talking about growth stage, when you want to show returns, you should show revenues. You want to show hundreds of vehicles running around. Here it's where it's happening. So investors like the story, because they've been theoretically monitoring it in other industries, such as urban mobility. And if you will go, either it will be the mayor of a city, CEO of a huge OEM, or a chairman of a venture capital, and ask him, when will urban mobility will be autonomous? you will get answers that differ around 15 years between the answers. And when you ask it about agriculture, the answer is now. And when you have this credibility and this understanding that the time has arrived, a very exciting time on that part. And we're talking about going on growth. And I think you will see not just both of us here in the industry, you'll see many more coming in with much more to come, because the world is huge and the pain is high. So this is on that side. And the other thing, just in conclusion, because we are creating autonomy now on that part, and not only with the blue-white robotics implementations, all of us, we are also creating the jobs of tomorrow. We're creating the operators of robotics. We're creating we're going alongside with the safety regulators and everybody. So amazing on that part. And it's great to be a pioneer. Thank you.
Shukran, Aubrey, any words from your side as well? How do you feel about where the industry is right now, and what are the prospects moving forward?
I think I'm completely agree with Ben. We believe that it helps also our business and helps a lot. Some of the money was spent to develop sensors that we are using, open source that we are leveraging, and mapping technology and so on. So we are making use of it with our unique solution, like a mixture. And also, in general, we believe some of the players will shift to low-speed vehicles. So the offering for project like us will be more and more attractive because of the implementation. So it's like that.
Yeah, and I think about it in a lot of ways. It undoubtedly helps us in most ways. And from my perspective, it becomes sort of social proof, and people believe that it is possible and it is coming. They don't know when, but they believe it. And so it helps us in a lot of different ways. I think we've talked about the technology, prices coming down, all of the tools. I'm sure everybody on this panel, we have access to similar tools, and we might use them in our tech stack because, as Ben said, we're not trying to build everything ourselves. We're trying to leverage what's out there, and the more investment there is, there's more available to all of us to just go to market quicker. And all the way down to even candidates in recruiting. We have people reach out to us who are very interested in automation and AVs, but the story that I hear in talking to folks is that they believe that it's going to take a really long time in passenger vehicles, and they want to do something that they can see soon. We're really impatient. And so, a young roboticist coming out of school really wants to see their tech out in the field working for customers and making money, and not in an R&D lab. So we have gains on the recruiting side, obviously on the fundraising side. Sure, some investors will come in and say, oh, I have some scar tissue from this AV investment I made, 5 years ago. And how are you different? We might come with a little bit of resistance, but once we show them, okay, guys, we're not in a lab here. We're out at customers making money. Like, look at it. And then we pipe them into a virtual demo of the machines running out 300 miles away in the middle of nowhere. Clicks instantaneously as to why a lot of people, not just us, believe that agriculture is where we see autonomous vehicles at scale first of many different industries. And so I think that we came in at a really fortuitous time.
Fantastic. That's very exciting to hear. And in this case, it's truly the case of a rising tide lifting all boats. So I think we're about at the end of our half an hour slot here. So I want to thank you all for sharing more about the companies you're working with, the technologies you've built, the business model you're operating under, who your partnerships are, what are the pain points, how the pandemic has changed the industry, and of course, what the larger vision is for the industry as it were as well. So thank you all for joining me today, and I'm looking forward to speaking to all of you again and getting updates and meeting again. And let's hope to have this panel again at EcoMotion in 2022.
Awesome.
Thank you very much for having us.
Thank you very much.
Cheers. Bye-bye.
Yep. Bye.